How's it going, everyone? Julio Gonzalez here again, and we're going to look at the escape hatch, which is a section from the React docs, as part of to understand how React works behind the scenes and be able to describe that so or college or any non-tech savvy, for example, business people, users, shareholders, we can now find a common ground so we can be on the same page. So I think this is the role also of the product owner, and as a way to know all the intrinsic nature of this technology and the jargon and what are the things that you need to do and that kind of thing, as well as now the soft skill required to manage not only teams but also to handle is the shareholders. So right now we're going to jump in. Let me jump straight forward to the React here as a way to now getting into this. This is part of the course that is taught by Steve Kinney, the front-end head front-end engineer at Temporal, which is a durable platform, a durable execution platform, which is an open source tool. Where here you can find is this particular record that is hosted on Front-End Masters, this online course, this online academy here. So because we're going to look at React performance, and as a way to look, and part of this is if you want to create now performant React application, you need to know how to write React components in the most performant way. And that lead us is to understand is, or to that invite us is to understand how now React works. So that's one of the reasons we're going to take a look at this. So once we know how React works, and I am able to describe how that things actually do what it's supposed to do and do the thing that it needs to do, then we can now is to focus our attention on this tool set that allows to detect React performance issues, and anytime we find them, we come up with this particular practice. So this is pretty much like you're untying a big knot. When you pull the right threads and then you apply the technique that you already know over and over and over, and until you solve that. So because the value proposition of the performances, at least in the context of React, is better to not doing stuff rather than doing it. And there's some corollaries to that, which is now with the React 18 give us this now way of defer some rendering, and that is it's better to do things, or it's faster to do stuff later than right now. So in any case, that's one of the reasons why we need to take a look at this, and I'm going to describe in the most quick way possible as a way to now make sense of how do we get here, because that's the idea behind this, is that now that you know all of this, and if you're able to describe what's going on, all right, how do we get here, as a way to finally is look at what are be the tool set that we need to create, especially when we identify any of these React performance issues. That's great. So because React, after all, is a JavaScript framework that allows to describe UI, we look at how can we describe this UI with JavaScript functions. How can we import React component, export components? What is this syntax that allows us to interact with JavaScript and the HTML in one single file called as the JSX, using the curly brackets as a way to now pass variables or interact in the JavaScript world to the HTML tag, and how we can create our components, and how can we now receive some components. Components, after all, are read-only. How can we now render components, conditional components, list rendering? How important is the key as a way to notify React, hey, we are going to keep track of these elements. So it's just pretty much like you have a folder with all of these several files. So when you keep track of that, you know what's going on, and now React can do its performance optimization when it needs to render that. Something that we're going to talk about that later, this rendering process. So we also look at the importance of create this component, these JavaScript functions, in a pure way. What does it mean by that? Is that given the same input, you always generate is the same output. And this, again, this is one of the properties of these pure functions, that it doesn't trigger any side effects outside of this, okay? And the benefit of that is because now we can just run this JavaScript function or this React component in any JavaScript environment, whether it is the JavaScript or the browser, the server, or workers, as well as we can use some memorization techniques to catch this function as a way to tell React, hey, I don't want you to calculate this, so let's going to skip this. Using useMemo, for example, or use callback as a way to hold is a reference, and as a way to catch this function reference, and let React as a way to catch this function reference between re-renderings. So hey, React, I don't want you to actually calculate, compute these functions or any other data, for example, object or states, only when I tell you to do that, only when there is an array of dependency, which is the second argument that we use, for example, in useMemo and in useCallback. So again, another benefit is that when using is or writing or React components in that particular way, is that we can safely stop the execution of that when you're passing down data, for example, right? So why this is important? Because once we know how can we describe our UI and how React see these components in a tree data structures, so pretty much like using this data structure that come from computer science, which is the this that come from this computer science, okay, where this is a way of how you can organize your data. So in terms of again, data structure is a computer science concept that allows to organize data. So pretty much like when you have now a fridge or a backpack, you put relevant things in each one of them. Fish and ice cream in your fridge, or a laptop, tablet, iPhone in your backpack. If you switch that, again, there's nothing wrong with that, but you know that's not you. Again, you'll get different outcomes. So, which is, if you store fish in your backpack, that'll be the outcome. That's what you want, after all. For how long? You know, you want to preserve that food or not. But again, that's the whole idea of these data structures, this way of organize the data. Okay? And this way now is an indicator of, or there are different data structures as a way to organize our data to cover a specific use case. Now we got arrays, we got hash, we got linked lists, we got double linked lists, also trees, graph. In this case, the software engineer at Facebook that create React, they use is a tree data structure. So this is a way of how can we now represent all of this in a visual way. How can we represent this in data? Okay. So we look at the render tree. That is, once we understand that, it's helpful to understand how the data flow goes through, as well as how can we identify any performance bottleneck. Okay. And the tree dependencies, which is what are the properties, the utility functions or reusable functions or code that you're going to pass to these React components as a way to now give them interactivity or specific a logic that you want to handle in this component. So if you, the whole idea here is to send a bundle that is small enough, and that's why we have, for example, some advanced techniques like code splitting and server-side rendering. Again, once we look at how can we describe the UI, okay, now it's time to look at how can we add interactivity, therefore through the event handlers. Because most of the time our React components, aka when we want to show something to the user, we want to show data, relevant data. For example, you have a bank app, or in your bank account, in your bank app, you want to see is your balance accounts or your transaction history or your credit card history. You know, all of this data. So the way of how can we now in React show this kind of data is through states. So states is a component's memory. Okay. So once we use that state, using the use state, we look at how can we now update our states through the event handlers by setting its state. We also look at the format of how can we make use of this hook in React. Okay, and what happens when we trigger that? In other words, when we update the state, which pass through this rendering mechanism. So you can pretty much think of this like an assembly line, where it is made of three phases. You got the trigger, you got the render, and then you got the commit. So the trigger is quite self-explanatory. It will detect if this change happened at the root of the event, of the root element in the render tree, or if this was caused by a component whose states, updates, or any of its ancestor. So whatever be the two cases, it will go to the render phase. If that happened at the root element, then you're going to create those elements, okay, using the create element for that. You can also take a look at their docs, okay. The rendering commit here, where the F are you? Yeah, on initial render, React will call. The root components here. So during the initial render, React will create the DOMs for that. That's exactly, it's using the create elements for that. Okay, so during the initial render, if this state update happens at the root element, I'm going to create is the DOM for that, using the create elements from the document interface, the brown of the browser. So you're gonna create all of these sections. The section one is the image, right? However, if this happened during a render, meaning a component actually state update, trigger a set update, trigger a state update, well, React will call the component that calls that. It's going to evaluate that, gonna store that data from evaluating is the props, the use states, as well as the event handlers, okay? and I will use that information in the next phase, but it will now, once it runs the React component function, which return is a GSX, it will evaluate if this contains more React components. If it is, it's gonna call them in a recursive way until there is no more components. So once now React traverses the entire render tree, it now knows the necessary data. It now holds the necessary data to apply the change to the DOM, which is on the commit phase. So if this happened at the root element, now what we're gonna do is to use the append on API, okay, which is this. It's gonna use the append child method from the node, and I think this is quite interesting to understand this because it uses the document create element methods. Hey, I'm going to create all of these sections, like h1 paragraph, during the rendering, and on the commit, now that he has that information, is going to append those elements to the DOM. Okay, if it was caused at the initial render. However, if this was during a re-render, what it's gonna do is to look at their React will calculate which of their property, if any, have changed its previous render. So it will take a look at if any of its property has changed, and it won't do anything with that information until the next step, which is the commit phase. So now React will apply the minimal necessary state update to the DOM, which was calculated while rendering, and it's only going to do that if they are different between renders. So if there are different between this this React component, this function component, if it is, okay, it's going to apply all the necessary, the minimal necessary updates to that. So once React does that, the browser will take those changes, and then it's going to paint your and then it's going to paint the UI for the user. So understanding this particular process is something that is quite convenient, especially if you're going to now serve content, for example, that is where SEO is required. Okay, so if you need SEO, now there's some frameworks out there, for example, like Next or Remix, that allow you to easily manage all of this thing. That is quite actually challenging, especially when you now have to switch between single page applications and server-side rendering, and then you have now others rendering a strategy. Okay, so but this mechanism, okay, is something that happens when we set the state, okay, which is great. So now we understand now this mechanism, what's going on here, especially when we use a state, a particular hook. So React have more hooks, but for our case, we focus our attention on use state. And how important is to think of state as a snapshot, because anytime React render that component, it will hold a state at that time. Okay, so if you think that you're going to have if you ask yourself when you're going to have the state value, you're gonna have that in the next render. So state's value change in the next render, and handling is that state during the event handler. So React fix that state within the event handler's render. So once we look at this, and how can we also see dispatch or send series of state updates as batching and how useful it is, for example, when you are dealing async operations in your event handlers, okay? For example, timeouts or any async operations, okay? As a way to now know the state that you're currently working at. We also look at how can we update objects and array in an state, which is great. How can we how do we need to always is rendering or return is a new state, part of the solid principle. Again, the idea of returning this new state in an object or in an array is because mutating objects is a mess. So if you come from object-oriented programming like Java or PHP, they have now a solid principle. Okay, there is a book called Solid that actually was written by Uncle Bob, where now it gather all of its experience and tell you if you're going to build now object-oriented programming, this is the principle that we must follow as a way to provide value, making the application maintainable and easy to extend. So the solid principle stands for single responsibility. These objects only have one thing and do one thing very well. Open to modification, close to extensions. If you want to add in more functionality to this object, it's better to create is a new subclass on that. And if you're going to create this subclass, must replace the parent class, known as the LISOC substitution. If you want to have a big object that wants to share common functionality to consumers, it is better to segregate that by interface. Interface segregation is another acronym here, the I. And then if you want to use some lower level models, instead of actually import them, you rely on an abstractions because you don't care about all of these finicky details that's going on. For example, if you are defining is a function to reset the password, regardless the underlying database that they're using, if this is a Postgre or Mongo or SQL, regardless of that, you just only care about is what you want to do, how you want to connect to the database. That's all. And then, for example, reset the password. So all of this is just to describe and to mention why here we are returning is a new state, and how by using IMER we can make it a consist state update logic. So once we know how can we add interactivity, how can we show the data and react to that data, okay, or that state, we need to look at how we're going to build our applications now that are scalable. Now we want to build is multiple user interfaces and how they're going to interact each other, and what is the React way of doing that? What is the recommended path from that? Managing a state, because states is one of the main source of bugs. So to prevent that, we look at how can we organize our states, how can we make the state update logic, how can we make the state update logic maintainable, and how can we pass down, and how can we pass data down, how can we pass data to distinct components. All right. So first we'll look at reacting to input, which is when you're having these components, you want to know is how you're going to define your states. And this is now the React way of defining user interface, which is doing it in a declarative way, not in an imperative. Which an imperative is like, for example, you want to create a password, you have now the input at the bottom here, and anytime, for example, user mouse the user mouse over, or the user okay, exactly. So anytime the user mouse down on that button, you're gonna show the text, and when it's mouse up, okay, when you click up, or then you want to show is the password, which is then you want to show is the obfuscate version of the password. Okay, so with that, okay, um, the idea here is how now can we write our components there in the React way. So React tells us that there is an imperative way of doing that. That's actually works well, but it's not scalable, especially when you want to create more and more interface, more and more UIs, and you want to connect all of this UI. It becomes quite hard to keep up. So that's why we have now this declarative approach. When you borrow a concept from the UI designer, you say, let's visualize all the different visual states. Let's go to determine what trigger those state updates, okay? Like a state machine, like a finite state machine. Represent those state using the use state in memory. Eliminate and avoid any non-essential state updates, and then connect the state or connect the event handler to set the state. So this process of how you're going to create your components here, how you're going to design your component, is now the first step of defining all of this UI. Okay, so it is important to start is with a mockup, as they mentioned here by the way. As they're mentioned here by the way, it's like, hey, start with a mockup, which must be provided by a designer. And if you don't have that, it's like, find one. Find some mock, okay? Find some mock. Okay, start with the mockup. So then break the UI into components hierarchy, like so. So break the UI into component hierarchy. Hey, I have this. Now let me break it down, break the UI into smaller components following its atomic design. So for example, here we got is the search, we got is the we got is the search bar here, we got is our product list, we got is our our product list, and inside of a product list we have is some cards as it is. For example, we can use this a product table as well. Not a big fan of this product table. Not a big fan of table, honestly. They're not responsive. Okay, but we can start is with the filterable product search. So we got is the search bar. We got is the product list. We got is our list items here, as well as the now filterable product table. Okay, so this is just to make sense of how you can build your UI. All right, the React way. So now that we look at what we need first, which is the mockup, and then you're going to break the UI into components hierarchy, then start to build is a static version in React. Okay, then let's go into now build a static version in React. Okay, it's going to build a static version in React. So Exactly. So when you build this static version in React, okay, exactly. So when you build this static version in React, okay, and when you need to actually find the minimal but complete representation of the UI, determine or represent those state using the useState, okay. As you're going to add more and more state, it is important to have a clear structure for that. And that is, well, these particular principles that React borrows from the database engineers, which is normalization, avoiding any redundance or duplicate data. So first, the state principle is, well, write your group state related close group state related each other, group state related next each other, group state related or group related state. Avoid any contradictory state. Avoid any redundant state. Can I get this information from its props or from its state? Avoid any duplicate states because it is hard to keep them sync. And avoid objects, avoid deeply nested objects in states. You really don't want that. You definitely don't want that because the state update logic becomes quite cumbersome to do that. So now we look at this, okay, as a way to say, all right, we know now this particular approach when it comes to find the minimal but complete representation of the UI, okay. Then we look at how can we organize our components as a way to share state across different. How can we now share a state across different components? And this is known as state lifting state up. So doing that, so for example, if you want to create a filterable search like this, which is pretty straightforward, you know, if you want to build a filterable search like this, so this is your input or this is your search, okay, and this is the product list, good, followed by the items, okay, you can have in here is the on your product here, on your product list, you have is now the items here, like so, followed by this, all right. But it's important to actually have is the structure here of how the thing is gonna look like. So having that, okay, having that, and when it comes to actually now share the states across different components, not only for product filtering but also for other kind of applications, UI elements, it is important to understand that you will choose which components owns that state. Therefore, that will be the source of truth of all of the other components that make use of that state, which is a concept that now is from Redux. What it tells you is that, hey, I'm going to hold is the app level state of your applications, and anytime you want to consume that or update that, there is a way of how you can do that. Okay, they dispatch actions, they use selector as a way to pick the proper state for that. So the idea here of this sharing objects here, sharing state between components, is that we can now have this mental model as a way to create more ambitious UI, and follow also is the thinking in React way. So you need the mockup. You're going to break the UI into several components. You're gonna build the minimal. You're gonna build a static version in React. Okay. You're gonna build a static version in React. Then you're going to find the minimal but complete representation of the UI state. Okay, which is like the most important principle for structured state is to keep dry, figuring out the absolute minimal representation of the state. Now think of all the piece of data in this example application. The original list of product, the search text, the search text the user has entered, the value of the checkbox, the filter list of product. But now you have to think of all of the different pieces of data. The original list of product, the search text the user has entered, the value of the checkbox, the filter list of product. Which of these are state? Identify the ones that are not. Okay, so anything that you need to remember or to store, okay, that's actually is an state. But if that remains unchanged, so does it remain unchanged over time? Okay. Okay, does it remain unchanged over time? So if so, is it in a state? If it is passed a pattern via props, is it in a state? Can you compute that? Okay, based on its state or props? Definitely is in a state. So what's left is probably a state, right? But again, this is the way of how when you're going to create your applications. It is interesting to take a look at that. Something that I'm gonna build is this chat or this drag and drop API for that, as a way to understand that how that things work. That'll be quite convenient and compelling. To look at how that particularly drag and drop functionality actually works and how can we work with that. And yeah, okay. So then also, now that I know why this is not a technical term, but especially when you're going to share your state across different components, how important it is to think in terms of how you're going to design these components and what capability is offered. Meaning is this components is the information here is an state, okay? So this is now a control. So if the information, when you write your component, when you write your React component, is the information is an state? Do we need to remember that information? Well, so now this is a uncontrolled component, which is served as a configuration from other components. The other is if this component data is received by its props, this is called as the uncontrolled the control component. Again, this is just terminology here as a way, again, when you're writing your React components, how you're going to design them and how to talk about in terms of the design and its capability. Because when you're starting to now have, when you need to deal with more and more states, therefore, when your state needs to react to more inputs, so for example, on change, on mouse over, copy and paste, so the more inputs a state needs to react, the more likely is, the more compelling is to use a maintainable way to state our updates. which is using a reducer. So reducer is just a fancy word to say, hey, this is a function, JavaScript function. It takes an action, it takes a state as the first argument, followed by an action to generate a new state out of this. As a way to tell React, this is the new state that I want you to update. Please do your magic. Do your thing. So, when we look at this, this React or this reducer is something that is useful, especially as I mentioned before, when you have to react to several input like that. So, for example, you have now a list you are going to build as a chat. You have now at the left side is all of your contact, and the right side you have is now your at the right side you have is a text box, and when you want is to switch between different chats, okay, you want is to also is not only find a way to trigger the proper state update, but to reset that state. For example, if you're talking to Bob, hey, reset the state with Bob. Hey, if you're talking to Alice, reset the state, the chat window to Alice. So to preserve the state and reset the state, React states are React states are tied to the position in the render tree. And this is important because now when you want to update, once you want to keep or reset the state updates, if you have two components, if you have the same component in the same position, React will keep that state. If you now are having different components at the same position, React will reset that state. And if you want to reset the state of the same component in the same position, you can use or render the component in a different position, or use the key as a way to notify React, hey, this is I want you to keep track of this for me. So anytime I trigger that, okay, let's go to do that. So on that, and as we move on to actually pass down data to different components using context, which is an alternative, which is an alternative of passing data through props. Because if you need to pass data through distant child's component, it's important to. So if any of the elements inside in the change is removed for some reason, let's say you want to show this image here and then you remove that, then you break the entire data flow. So to prevent this, you want this to create a context where then you're going to use the context from the component that you need to, using the use context hook, and return the or provide that context. After all, when you create a context, it doesn't hold any information. It's just it represents is which context all the components can access or can use this or provide them. So one of the caveats of this use context is that, for example, when you need to React will re-renders any child components that use that context starting from the provider when the input value change. So that might be useful, for example, for theming. Okay, so when you want that components to be aware of its surroundings. So hey, I want you to now show this. like a dark mode, or for authentication. It's like, hey, this user now can be available to all of these other components. Okay, if you want to read this data, here it is. You have that. Uh, yeah, slow down a little bit here, because it's not only for theming, but also for user. It's not only for theming, but also for small piece of data. For example, authentication or the data here, as well as the. For example, the browser, the React router is actually using that context as a way to tell you is what is the URL that this user is currently at. And when you want to now make your state update logic consistent using reducers. So that's an advanced topic, which is when you want to now scale your state management. React mentioned you can use context followed by the providers, and the way of how you're gonna do that is you create a context from the state for the dispatch. You write your provider functions, okay, that is in there when you're going to now bind the context for that. So for example here, okay, so it's in there when you're going to define is the use reducer. In that file you can use or define is the reducer function, okay, and that component that you're going to export and that function that you export, which will have is the context provider, the context provider, the context provider, followed by the state and the value, okay, the state and the dispatcher, and when you followed by the children that you want to pass down, and when you put that in the and when you put that in your app, when you put that in your entry point, for example, as a task provider, now all of these components are aware of this, and you have now a systematic way to keep the state update logic. The trade-off here is, as I mentioned, React re-renders child components whose use this context starting from the provider that value change. So what happened is that the more state that you got in there, the more indeterministic it becomes. So in any case, the recommendation here is that use that, but start with props. If you can start with prop, then extract the component into a GSX element, and then you can pass the data there. If you're not, if you can't, so alright, then let's go to use context for that. And when it comes to now control or sync with external systems in the React components. So for example, you want to now set the input using the browser API, or pause and play and pause a video implemented without React, or you want to connect and listen to message from a remote server. The idea here is that when you want to connect your React components with other systems, they provide you now this escape hatches here. So we look at we're gonna look at how can we now remember information without re-rendering, okay? How to access the DOM elements managed by React, how to synchronize component with external systems, how to remove unnecessary effects from your components, and how an effect lifecycle is different from a component. So, because, which is something that, again, Brian Hall mentioned that, okay? Yeah, again, Brian Hall mentioned that, and to me was quite interesting. That is, even though that he showed this intermediate React, okay? The whole point of this is to look at not only look at the reason why React create this kind of hooks as a way to make sense of them, and remember that after all all of us we're not going to have is React problems or Facebook problems. If you have that, please send me a check. I gladly to work with you. So good. So here we look at how to remember information without rendering using the useRef hook, okay, as a way to allow us is to remember things without triggering a re-rendering. Okay, you can think of this useRef as a special as a special pocket, okay, something that they mention here. It's like a secret pocket that React doesn't keep track of this. So if you want to make use of this, you will have now this property called ref as a way to actually, well, having this secret pocket, having this memory without re-rendering. Okay, so now that we got is this particular hooks that allows us to remember pretty much like a state that allows to remember things between renderings. So once we React call that and evaluate that, and we also have now this memory without trigger a rendering. Okay, so for example, like this. You may wonder, why do I need to actually use this? Well, what you want to implement is timeout. Okay, again, working with external systems and take control or synchronize with them. So for example, in the case of timeout, you want us to hold a reference when you're going to implement this stopwatch here. Okay, if you're going to implement a stopwatch here, like that, it's like, ooh, it's gonna continue to count. So if you want to now implement this, all right, and you want to stop that, that's what you want, you know, and this is a way of how can we implement this. So okay, fine, we actually set the interval, all right, but if we want to now stop this, we can just define another button here. Okay, now we can define another button here and say, hey, handle stop. Of course, you're going to complain about it, but because we're going to now interact with external systems from this JavaScript function, React component, okay? So in this particular context, since we are now starting as a counter here, we're saying, hey, set interval this, and now I want you to update the state here as a way to trigger that for any 10 seconds, 10 milliseconds here, and that's it. So the whole point of this is that on handle stop, we're gonna say we need to actually find a way to clear this interval. Okay, somehow we need to actually hold a reference for that. And what we're going to use here is the element, or you can say it's timeout ID ref, okay, or time ref, like so. When you say, okay, let me use the reference here, this is the secret pocket here, use ref, and here what I'm gonna do is, because I want to hold is a reference on this set interval, okay, I'm gonna do is this. In fact, I'm gonna do this like so, okay, and then I'm going to reassign this time ref here dot current, okay, and by doing is this, I want this to now, when you handle stop, is to say clear interval of the time ref dot current, right? That's all. So you start and then you stop. Oh, and then you stop. And then you stop here, and then you stop, and then you start again, and then you stop, start again, and then you stop. This is now again how we're using this secret pocket. We use ref. You can now to hold a reference as a way to control this, or to later on synchronize this, and use ref. Between the difference between the ref and the state is that use ref is mutable. Use ref doesn't trigger any doesn't trigger re-renders. Okay, so for example, with use states, you need to use is the use state for that. It triggers re-renders when you change it. Okay, it is immutable, which means that you must modify. You must use a state setting function to modify the state variables to queue a render, a re-render. You can read state at any time. However, each render has its own snapshot of state, which does not change. Okay. Yep. However, each render has its own snapshot. Yeah, you can read state at any time. However, each render has its own snapshot of state, which does not change. So during a render, state owns a snapshot. State now allows you to access to this snapshot that doesn't change. Well, now here you shouldn't read or write the current value during rendering. So the whole point of looking at this specific reference is that, as I mentioned in the docs, this is like a magic, or this is like a secret pocket. Okay, it's not magic, because technology isn't indistinguished from magic. So here is you have the secret pocket where it allows you to now access or to remember things without trigger re-renders. So again, we'll look at what will be the main use case for this. Is that when you need to store the timeout ID, storing or manipulating DOM element, okay, which is useful, which we cover in the next page. Storing objects, or storing other objects that are necessary to calculate GSX. If your component needs to store some value, but it doesn't impact the rendering logic, choose ref. Hey, I need to compute something, or I need to store something, but it doesn't impact the rend. Oh, okay. Hey, I need you to store something. Starting with the question is something important. Hey, I need you to store something. Does this impact the rendering? If it is, use a state. If it's not, use this secret pocket. Okay, best practice for ref. Treat ref as an escape hatches. Ref are useful when you work with external system or browser API. If much of your application logic on data flow relies on ref, you might want to rethink your approach. Don't read or write ref current during rendering. If some information is needed during rendering, use state inset. Exactly. Since React doesn't know when the ref.current changed because it doesn't keep track of that, even reading it while rendering makes your component's behavior difficult to predict. Exactly. The only exception for this is code like if the current, if there is no element, then assign a new thing, which only set the ref once during the first render. Limitation of React state don't apply to ref. For example, state add like snapshot. Exactly. State add like snapshot for every render. So anytime React need to compute this function, state act as a snapshot. This is the current data that you have. This and doesn't update synchronously. But when it doesn't update synchronously, which is here. And doesn't update synchronously. Exactly. And doesn't update synchronously. Exactly. And doesn't update synchronously. So limitation of React state don't apply to ref. Okay, cool. Doesn't update synchronously, but when you mutate the current value of ref, it changes immediately. This is because ref itself is a regular JavaScript object, so it behaves like one. So you also don't need to worry about avoiding mutation. Okay, for example, like this, avoiding mutation when you work with a ref, as long as the object you're mutating isn't used for rendering. React doesn't care what you do with the ref or if it is content, because React doesn't keep track of this. This is like a special pocket where you can store things that when you don't need during rendering, good. Which allows you to now or hold reference for external system. Okay. For example, the main use case here is to store the timeout ID. Store the timeout ID. Storing and manipulating DOM elements, and storing other objects that are necessary to calculate the GSX. Which means that are necessary to during renderings, that are necessary to calculate the GSX. Okay. So here we got is this, fix a broken chain input. Exactly, fix a broken chain input. You're gonna have is this, let timeout ID. And so far so good. It's like use ref. Okay. And here what you got is this, use ref. This is it. We're gonna now holding the timeout here as a reference for that, And when we're going to clear that amount, this is exactly what we're going to do. Exactly. Ooh, that's my dot. Because it's the timeout.current, bro. Similar to this. This is the way of how we can actually is store that data. You know, that's right. So next one is the fix a component failure to re-render. Because now you're gonna use it in a state. There's no need to do this. Fix the bouncing and debounce here. Like so. So you can create a useRef for that as a way to anytime you click here, you're gonna clear the previous timeout, okay, and then all right. Especially when you're gonna handle is debounce. Especially if you're gonna handle is debounce. And the next challenge is this: read the latest state. In this example, after press send, there is a small delay before the showing. Type hello, press send, and then quickly edit the input again. You say hello. And it's sending that twice here. Okay. Which was the value at the state at the time the button was clicked. Usually this behavior is what you want in an app. However, there may occasional case when you want to some asynchronous code to read the latest version of some state. You can think of a way to make an alert show the current input rather than what it was at the time of the click. So what you can do is you got this set alert, all right. You create a reference for this. So what is what you want? Can you think of a way to make the alert show the current input? Can you think a way to make the alert show the current input text rather than what it was in the time of a click? Well, we can hold a reference from that text, okay, and send is the latest value for that. How so? We're going to define here we're going to define is the reference to hold the exactly reference to hold the reference to hold the value yep reference to hold the latest okay reference to hold the latest input value here reference to hold the latest input value okay, and then show the latest input value. So we can do is using a ref. You can say is input ref here, like use ref. Okay, and then with this input ref, okay, we can say is input ref or ref like this. So we hold now is a reference for that. This is a property that now React allows to do, and we're gonna get is now the input ref dot current dot value. So that's it. So we can say hello, and then 1, And of course, you're going to send that. You're going to send that. You know, that's it. That's it. So we hold this reference, and now we're showing is what is the latest value of that. Hello. You know, that's pretty interesting. It's pretty interesting that how we can store this reference as a JavaScript object here using ref, okay, and then show that proper data. So now this is the next section, which is manipulating the DOM with ref. React automatically update the DOM to match your render output, so your components will often need to manipulate it. However, sometimes you might need access to the DOM elements managed by React. For example, to focus on a node, scroll to, okay, to focus on a node, to scroll to it, or measuring its size and position. There is no built-in way to do these things in React. Okay. So you need a ref to the DOM node. When you want this to, for example, manipulate DOM elements, React automatically updates the DOM to match your render output, so your components will often need to manipulate it. However, sometimes you might need access to the DOM elements managed by React. For example, to focus a node, scroll to it, but I want you to manipulate this node, okay, as a way to look. Okay, I want you manipulating the DOM with ref. It's like, hey, I want you to now scroll to this position or measure the size of this element. Measure the size and its position. So there is no built-in way to do these things in React. So you will need a ref to the DOM node. You will learn how to access the DOM node managed by React with ref attributes, how the ref GSX attribute related to the useRef hook, how to access another component's DOM node, and in which case it's safe to modify the DOM managed by React. So getting a ref of a node, pretty much like this, and you pass this. So how we can now use is a ref to manipulate DOM. Manipulate the DOM with ref. The useRef hooks returns an object with a single property called current. Initially, my ref current will be null. So when React create DOM nodes for this div, React will put a reference to this node into the myref.current, because this is the secret store. Okay, you can then access to this DOM from your event handler. You can access this DOM node from your event handler and use the built-in browser APIs defined. And use the built-in browser APIs defined on the element. Okay, instance property of that element. So you have now client height, client left, client top, client width. Read-only property is 0 for elements with no CSS or inline boxes otherwise. Client width and client height. Of an element. Offset. client width and offset width is including the border. Get bound client here. The return value is a DOM rect object, which is the smallest rectangle which contains the entire element, including its padding and border width. The left, top, right, bottom, x, y, width, and height property describe the position and size of overall rectangle in pixels. Properties other than width and height are relative to the top left of the viewport. The width and height properties of the downRect object returned by the method include the padding and border width, and not only the content width and height. In the standard box model, this will be equal to the width and height property. But again, okay, this is what is returned. Parameter is none, but in return is this. Using this imperative approach, but this is an object. Makes sense. Okay, and this is return is this. It return is this. This return is a shape object with x, y, width, height, top, right, bottom, and left. But this is on the scroll. Exactly where, okay. Okay. Get bound client rect. Get bounding client rect. Okay. Oh, cool. So, but that's quite interesting because now this useRef, where we can use this attribute ref to point this specific element, it will get this reference for us that we can have access in our event handlers and use the built-in browser API defined. For example, like this. Wait a single moment. What's going on here? So ref is an attribute for React where we can now attach this use reference, or we can store is this element to be used in an event handlers and use the built-in browser API element defined on it. So it returned this, okay, it returned this browser API. Again, what is doing this? So ref is a special property that allows to use the useRef hooks returns an object with a single property called current. Initially, my ref current will be null when React create a DOM node for this div. React will put a reference to this node exactly. React is putting a reference to this node on that useRef, and under the current you have now is the browser API. You have now is the element here for that. So you can now have access to the element here right now. the Web API elements for them. Exactly. Focusing on text input here, scrolling to an element. Scrolling to view. Scrolling to view from element. Ah, okay. Scrolling to view. But that actually doesn't work. How to manage a list of refs using a ref callback. In the example above, there is a predefined number of refs. However, sometimes you might need a ref to each item in the list, so you don't know how many you will have. Sometimes like this wouldn't work. This is because hooks must only be called on the top level of your components. Of course, hooks must be called on the top of component. You can call useRef in a loop, in a condition, or inside of a map. One possible way around this is to get the single ref of their parent element and then use a DOM manipulating method like query selectors to find the individual child node from it. However, this is brittle and can break if your DOM structure changed. Another solution is to pass a function to the ref attribute. This is called a ref callback. React will call your ref callback with the DOM node when it is time to set the ref, and with null when it is time to clear it. This lets you maintain your own array or a map and access any ref by its index or some kind of ID. Oh, scroll to cat. you have now a reference here of each one of those nodes. You can is hold a reference here since this is a new map. Get map. Okay, you're gonna call this inside of the handler here, and if the node that you're receiving exists, set the map for that. Otherwise, do this. In this example, ironRef don't hold a single node DOM node. Instead, it holds a map from items ID, and it is funny because it's showing them as a list. But instead of returning them like this, it is putting all of its elements like that. No, but they provide some. Yeah, they provide some sort of style for this. They provide some sort of a style for this. Exactly. ironRef doesn't hold any single DOM node. Instead, it holds a map from an item ID to a DOM. Ref can hold any values, and the ref callbacks on every list item takes care of to update the map. So in this case, is by calling is this ref here. Okay. So by calling is this ref there. Okay, on click you're gonna scroll to cat. Cat list is 0. And the scroll to cat is say, hey, here we create a map from this. When we hold the reference for all of these elements, okay, we can get now the current node and then scroll to that. Oh, we can, okay, we can scroll to that element. Again, this is, this is like you read individual DOM nodes from the map later in Canary. This example shows another approach for managing the map here. But this is an experimental feature. Accessing DOMs and other components. Again, you can hold as a reference and from there apply some of the property of that element. But again, if you are manipulating or reading in this case, if you are reading that, it's like so when we attach the ref, you get is this. Flushing state update synchronously with flush sync. And best practice for DOM manipulation with ref. And I get it. Ref are an escape hatch you should only use when you have stepped outside React. Common example of including managing focus, scroll position, or calling browser API that React does not expose. If you stick to non-destructured actions like focusing and scrolling, you shouldn't encounter any problems. However, if you try to modify the DOM manually, you can risk conflict with the change React is making. To illustrate this problem, this is example including a welcome message and 2 buttons. The first button toggles it is presence using conditional rendering and state. You will usually do in React. Oh, but this is now. Okay. Toggling with set state and toggling is with the useRef. Avoid changing DOM nodes managed by React. However, this doesn't mean that you can't do it at all. It requires caution. You can safely modify part of the DOM that React has not reason to update. For example, here, if you put this here, you are telling to React, hey, we're going to now update this. As a way to not only have control and synchronize that. It doesn't work here. Play and pause a video. Okay. Okay. Play and pause a video. Here we need to find is a reference here and attach that, so when we handle that event, we say is play and pause or play. And here on handle click, you are actually setting instead is play, next is playing. So this actually is properly updating the state, okay? But we need to control if this external system, or in this case this element here, and when you want to control that, for example like this, because we're going to mutate that, unlike an state, you don't mutate. That's the reason why we use cons, as well as the let. Yep. So here we say is video ref, use ref for that, and then let me now append that. So React give you is a reference of these elements, holds that here under the current, and now you can is mutate or change this object by saying video ref dot current, okay? And because now we're working is with the video, what will be the element that you want to work with videos, you know? So this is all about the elements, okay? This is all about the elements. All of these elements actually share this. All of these elements actually share this. But when we take a look now at the video, HTML video tag, like this, which is of course comes from the element. If I have access to the media element and HTML element and node and event target, here this is the instance that allows you to do this. Okay. Instance property, high poster video high width. Instance method, request picture in picture. That's right, and the event. Enter picture in, leave picture in, and resize. Inherit from HTML element and all of this. Okay. And this is inheriting from all of this, related pages, and then you got it. But this is HTML video element. Implemented by the video element, the HTML video element interface provides several special property and methods for manipulating video object. And it also inherits property and method of the HTML media element. The list of supported media formats is this. Disable picture in picture, instance method, cancel video frame callback, get video playback quality, request. We got is this HTML media element. Both inherit this interface. Then you have now instance property, okay, like this. So pause, Okay, the video and audio share this HTML media element. Audio play. So you have now pause and the other is play. Okay. So we can check is actually if it's pause. You can say, hey, if the video code is pause, okay. So if video current is pause, well, I want you to now enable that, which is an event or play. Exactly. Play. You say video ref dot play, video current dot play. Say, hey, play. Otherwise, well, video ref dot current pause, but as a method. Exactly. Instance model from the HTML media element. So now we got this, replace and pause as expected. Wait, what? Exactly. Or we can match is with this state, right? Because we would like this to match is with the current state. So we want to match it with the current state. Exactly. What we do is this. Exactly, because we want to match it with our state. And then sync with external system. Like this. The other is focus the search field. This is quite trivial, by the way. Quite trivial. Quite trivial. And say is this. Say input ref as a way to actually now hold this or store this the data without trigger a re-rendering. And when we now listen to this event here on click, we say, all right, I want you to now trigger this handle click here. So handle click which is a function. We can also define this as an arrow function as well. Where here you say is like, no, it's gonna define this as a function here. So handle click. Okay. So if you want to use an arrow function, it's because you want this to create is, yeah, you want to create is, now you want to make the value of this be a closure. So in our case, on click and handle click, the TLDR of this is that we need to do is this: on click, handle click. Is like, yeah, we're gonna get this, okay, and we're gonna to actually is enables or points to that, which is this. Ref is a way to tell React, hey, I want you to hold this reference, okay, and store it into the current input ref.current. And since this is now an element, okay, not an HTML element, it's an element here. The anatomy of an HTML element, this is something important to know. Class, attributes and its value, enclosed text, enclose the text context, closing tag, opening tag, and then you got it. So you got, I want to take a look at the attribute, no. I want to take a look at the defining custom elements, getting started with HTML. Jesus. Glossary, but this is a glossary. Element. Here, from the web API, from the DOM, is this. So now this represent is all of these attributes. Okay. So it's actually interesting. It represents all of these attributes. Instance after before, but for our case, since we want this to work is with the HTML input element, okay, I want to now take a look at what are the properties that we can have access to. For example, focus. Do we have something related to focus? It seems no. We got select and we got an invalid as an event. Interesting. But let me take a look now as the HTML element, not as the instance property, is as those who can actually focus. Okay, it's part of the HTML element here. So you say now focus on that. Focus on that. So now when we click here, it's going to, in theory, given this reference that we have here, we are triggering that. So our focus should be there. Yep, pretty straightforward. Pretty straightforward. So far, so good. So here we got now scrolling an image carousel. The image carousel has a next button then that switch the active image. Make the gallery scroll horizontally. To activate the image on click, you will want to call scroll into window on the DOM node to activate the image. To activate the image, scrolling an image carousel. So because when we click here, we want is to now actually iterate through all of these elements, and one of the examples here is to scroll into an element. Okay. All right. Okay. That'll be all for this video. Take care. Bye bye.